In today's video, we're going to look at the reactions between acids and different kinds of bases, including metal oxides, metal hydroxides, and metal carbonates, all of which would be classed as neutralization reactions. And at the end, we'll see how we can make soluble salts using an insoluble base. Let's start with the metal oxides and hydroxides. Whenever either of these react with an acid, they'll always form a salt plus water. For example, if we combined hydrochloric acid with sodium oxide, which is a metal oxide, the positive sodium ions and negative chloride ions would combine to form sodium chloride, which is the salt, while the hydrogen and oxygen would form water. And if we balanced it, it would look like this. Or if we added sulfuric acid to a metal hydroxide, like potassium hydroxide, each of the negative sulfate ions, which are 2 minus, would combine with 2 of the potassium 1 plus ions to form our salt K2SO4, which is potassium sulfate. And just like before, we'd also get water and then have to balance it. These types of reactions always follow the same pattern. You take the negative ion from the acid and combine it with the positive ion from the base to form a salt, and you always get water. You just have to be careful to get your salt formula right and balance the whole thing correctly. Now, when acids react with metal carbonates, the reaction's pretty similar. They still form a salt and water, but we also get carbon dioxide. So if we took nitric acid and combined it with calcium carbonate, then just like before, we'd take the positive calcium ion from our base and combine it with the negative nitrate ions from the acid. But because the nitrate only has a 1 minus charge, while the calcium's 2 plus, we'd need 2 of them to form calcium nitrate, which would be our salt. And then we'd also get water and carbon dioxide and have to check it's balanced. Now, all of the salts that we've covered so far have been soluble in water, meaning they dissolve. So if we want to make a soluble salt, all we need to do is react an acid with an insoluble base, like a metal oxide, hydroxide, or carbonate. In practice though, to actually carry out this reaction, there are a few different steps that you need to know. First, you place some dilute acid, for example hydrochloric acid, in a beaker, and gently heat it with a Bunsen burner. Then you keep adding insoluble base, for example copper oxide, a little bit at a time. At first, it will keep disappearing as it reacts to form aqueous copper chloride and water. But then as you add more, you'll see that some of the base is no longer disappearing. So at this point, we know that the base must be in excess, and we'll have neutralized all of the acid. The next step is to filter out all of this excess copper oxide, using filter paper and a filter funnel, and what we have left should be the dissolved form of our soluble salt, in this case copper chloride. In order to get pure solid crystals of copper chloride though, we'd need to gently heat up our now filtered solution and evaporate off some of the water. To do this, we'd want to use a water bath or an electric heater rather than a Bunsen burner, because we don't want to heat up the solution too much and risk damaging our salt. Once we've evaporated a bit of the water off and we start to see crystals forming, we can stop heating it and leave it to cool, which will cause even more crystals to form. We then filter these crystals out using filter paper and funnel again, and then dry our crystals, either by dabbing them with filter paper or leaving them somewhere warm. And that's it. We've used an insoluble base, plus acid, to make crystals of a soluble salt.